to talk about some updates to Boeing CST-100 Starliner. We have NASA and Boeing representatives on the line to answer your questions. We'll first go through some opening remarks before we get to your questions, but that will take up the majority of our time today. On the line, we have Steve Stitch, Manager of NASA's Commercial Crew Program. We have John Ballmer, Vice President and Program Manager of Boeing Commercial Crew Program. And we also have Michelle Parker, Chief Engineer of Boeing Space and Launch. Thanks to all of our participants for joining today. We'll first go around the room and start with some opening remarks. In the meantime, while we are starting with some of these initial comments, feel free to press *1 to those on the line to enter into our Q&A queue. And we'll call on you right after we're done with opening remarks, and that will take up the majority of our time today. So with that, I'll pass it over to Steve Stitch for opening remarks.
And I apologize for the interruption. This is the operator. Today's conference is being recorded. If you have any objections, you may disconnect at this time. And I apologize. You may proceed.
Yeah. Thanks, Gary. It's great to be here to talk about the progress. And the first thing I want to say is the Boeing NASA team is incredible. They are professionals, and they have been working through this investigation with a lot of rigor and care. Of course, the oxidizer is a hazardous commodity, and they've taken precautions along the way. We've made a lot of progress since we last talked. The team has worked through a lot of the items in the fault tree and had a lot of closures on that over the last month or so, using data from the vehicle as they do testing and also components offline to close out those items, and they'll work through a lot of the items in the fault tree over the next month or so. Michelle's going to talk more about it, but today's a pretty big day. After offloading oxidizer on the spacecraft in the last week, 2 of the valves have been removed, and those will go to the NASA Marshall Space Flight Center that has a really good CT scanner, like when you go in for a medical procedure. A lot of spaceflight hardware gets CT scanned, and there's a CT scanner there that will be used to look at the valves first, and then they'll go into a disassembly to look for the root cause. We also have our White Sands test facility at NASA involved. They have a long heritage with hypergolic propellants, and they'll be doing some testing. They have started some testing on 2 valves, which we started back in September, a long-term oxidizer exposure without moisture. We'll get some other valves out to White Sands and put them through a bunch of paces to replicate the environment in the C3PF, and then also at the VIF to go understand root cause. And of course, we've talked about, we'll fly when we're ready. We talked about the first half of next year as being a viable launch period, and I know John and Michelle will talk more about that. I'm incredibly proud of the team. They continue to work through the fault tree, continue to make progress, and we'll fly when we're ready. And I'll turn it over to John Ballmer, the Program Manager for Boeing.
Okay. Hey, thank you, Steve. I appreciate that. So I'd like to start with a thank you for all of you for your interest in our progress. I'd also like to thank NASA and Aerojet Rocketdyne. Their partnership in this process has been absolutely invaluable. And then, of course, I'd like to express my appreciation to the Starliner team. They're really taking this like consummate professionals. They're committed to solving this challenge and getting back to the launch pad. Proceeding is just a tremendous honor and responsibility of flying astronauts to the International Space Station. And that goes for the Boeing company as well. We are resolute in fulfilling our commitments that we've made to NASA to carry a crew back and forth to the International Space Station. So with that, let me share what we've set as our objective for OFT-2. And that is to get back to flight safely, and I stress safely, as soon as possible. So everything we've done up to this point and the path that we're developing going forward is going to enable us to meet that goal of getting back to flight safely and as soon as possible. We looked at the options of how to go forward, and we felt the best path was to proceed with the current service module. By keeping the same service module and crew module configuration, it's putting us somewhere in the first half of 2022. And, of course, that's pending spacecraft readiness, the availability of the Atlas V, getting a date on a range, and, of course, working with our ISS partners to ensure that we've got a port to dock. I've also, we have Michelle Parker with us today, and let me just give her a proper introduction. So Michelle is the Chief Engineer for Space and Launch Systems for the Boeing Company. She's responsible for not only the technical integrity success of Boeing Starliner, she's also responsible for engineering on the International Space Station, the Space Launch System, and satellite programs. So she has a lot of background and has been involved in helping us work the troubleshooting, the root cause investigation, and as we work through the remediation activities to develop the path forward for the spacecraft. So she's been an incredible partner, and that's why I asked her to be here with us today. She will take a lot of the technical questions, and I'll focus on the programmatic questions. And so, Michelle, over to you.
All right. Thank you, John. Before I go into some of the technical details, I also would like to express my appreciation to NASA and to Aerojet and this combined team that really has been working very diligently from the time that we've had the issue on the launch pad to today. It really couldn't be a better team, very knowledgeable, all the way down to the details of the propulsion system, as well as operations. And so really a great team working very, very closely together through a complex and difficult problem. So today I'm here at the Commercial Crew and Cargo Processing Facility. So downstairs, the vehicle is downstairs in High Bay. And as Steve already mentioned, it's been a big day for us today because we have removed 2 of the valves, and we are planning to remove a 3rd as well. So we've gotten 2 of the valves successfully off of the vehicle, and the team's proceeding on to the 3rd valve. And those will be important for us in order for us to verify what we believe is the most probable cause of the issue. So we'll take those valves, we'll pack them up, and we will send them out to Marshall Space Flight Center, where, as Steve said, they'll get CT scanned and then be further disassembled to verify the root cause. So let me take us back a little bit. So back on August 3rd, we were on the launch pad. We were progressing through our countdown launch procedure through nominal operations, and about 4.5 hours prior to launch is a standard cycling of the valves. That's just part of our normal launch countdown procedure. And at that time, we had 13 of the 24 valves, which would not cycle for us. And at that time, we determined that we would not be launching that day. So since that time, we conducted troubleshooting efforts at the launch pad and then also at the vertical integration facility. So we did spend some time there digging into the root cause, establishing our fault tree, and doing investigation on the vehicle to pinpoint what was going on with the valves. At that time, in the vertical integration facility, we were able to free 19 of those 13 stuck valves. So through a combination of higher voltages, some external power to the valves, and some heating, we were able to free 9 of those 13 valves. But at the end of the day, there were 4 that remained in a stuck configuration that we were unable to free at the vertical integration facility, and we therefore decided to roll back to the factory, which is where we are now. Also during that time, the team, again, that combined team, NASA, Aerojet, Boeing, put together an extensive fault tree on all potential causes that could be contributing to this condition. Very, very quickly, we were able to eliminate a number of those items, such as wiring or bad instrumentation that was just giving us faulty readings. Those were eliminated quickly from the fault tree. And also very quickly, the team really honed in on this most probable cause of an interaction between the oxidizer that is in the system and water or humidity in the valves as well, combining to form nitric acid and corrosion products, which then contributed to the sticking of the valve. So, honed in on that pretty quickly, but again, working rigorously through the fault tree to make sure that we had supporting data to be clearing off the other branches on the tree. And we've really remained with that probable cause for the majority of this investigation. We did roll back to the factory, where we were able to gain better access to the valves by removal of some of the panels and such on the vehicle, and be able to get direct access to those valves to perform additional troubleshooting efforts, which again included the addition of higher voltages that we also were able to do at the VIF, and then additional heating to the external portions of the valve, and we were able to free additional valves. We also took 3 valves and we disassembled the dry side of the valve, so not where the oxidizer is, but on the ends of the valve are dry areas, one side including the solenoid that operates the valve, one side containing the valve positioning indicator that tells us whether the valve is open or closed. It provides the telemetry as to whether the valve is open or closed. We were able to disassemble 3 different valves to look in and see if we saw any anomalous behavior in there. We did, the solenoid side of the valve was fairly clean. The valve positioning indicator side, as we disassembled that, we did get some indications of oxidizer, as well as we saw corrosion products in the form of aluminum nitrates, which, again, supported the root cause that we have been pointing at. So that investigation was complete, and again, continued to support what we believe was the root cause. From there, we've moved into remediation efforts. As John said, we believe our quickest path back to launch is to use Service Module 2, again, assuming that we can do that in a safe manner that ensures operation of the vehicle. So we've continued to look at remediation efforts there, including adding desiccant to the valves to prevent further moisture ingression, as well as looking at adding heaters, because also as part of our troubleshooting efforts, we did put heat externally to the valves, which allowed the 3 of the remaining 4 valves to free up, and we have 1 valve that remains stuck closed, but we've reserved that one. We haven't tried this troubleshooting method because we want to preserve that for further investigation, and that's one of the valves that we're removing. So looking at going forward with Service Module 2, what remediation efforts would need to be there for Service Module 2. So we've spent some time on the vehicle looking at that and testing that as well. So that's been part of our investigation. And as we mentioned today, last week, we removed the oxidizer from the system. The team did a really great job of working through a complex operation to get that volatile commodity off of the spacecraft. So that has been removed, and then they proceeded into removing the valves, which is where we are today, removing those 2 valves, and the 3rd will be removed as well. So, really where we are right now is 3 areas that we need to continue to work. The verification, which will include those removed valves, going down to Marshall Flight Center for CT scan and disassembly to look at corrosion products there, remediation that we would need for flight, and then flight rationale that will work very closely with NASA, both the Commercial Crew Program and ISS. So those are kind of the 3 focus areas that we're working through. And then just to say a little bit about this phenomenon of the corrosion. These valves do have Teflon seals in them. The Teflon is chosen because it's compatible with the oxidizer, but it is known that oxidizer will permeate through Teflon. So that's a known phenomenon that's been seen previously, depending on the length of time that commodity is in the system. But the Teflon is chosen because it is compatible with the oxidizer. We've been able to rule out a number of areas, like I said, with regard to wiring, instrumentation, the propulsion controller itself. So we are down now those 13 valves that have been stuck. We've been able to free up 12 of them, with the 1 that we're preserving for further verification efforts. So we haven't really tried all of our tricks on that one. So that one is one of the valves we're removing to send to Marshall. And, I'd just like to reiterate what John said. Our goal is really to get back to flight safely. We will ensure that everything is safe and that all procedures are followed safely and as quickly as possible. We really are excited to be able to launch this vehicle and test it out. It is important that we do it right, and the team's been very diligent about working through all of the potential causes and planning out all of the investigations and remediation. It is a complex issue. It's a complex issue that we've had to work through. So we definitely have been methodical about that. And again, teams working together very closely every day to use sound engineering processes to get through that. And really looking forward to these next couple steps of verification, getting the valves remediated, and determining when it's safe and prudent to fly. And with that, I'll turn it back to Gary.
All right, thank you, Michelle, and thanks to our briefers for those initial remarks. We'll now open it up for questions. Again, if you're on the line, you have to press *1 to enter into our queue, and I'll read off your name and affiliation. Whenever you're called, please state to whom you'd like to direct your question, and we'll take Q&A for the rest of our time today. So with that, let's start off on our queue with Bill Harwood from CBS News.
Hi, it's Bill Harwood, CBS, just across the street from you. I'm curious how the water/humidity got into the valves. I mean, lots of rockets use these propellants, but this seems to have caught everyone off guard, and I'm kind of wondering about that. I'm wondering if the rocket being exposed at Pad 41 for a couple of days in Florida weather was a factor. And I guess what I'm really asking is, is this something nobody thought about? I mean, I know you guys think about stuff like this, but I'm really curious how it happened. Thanks.
Yeah, I can take that one. So I think it is also important to note that we have seen this propulsion system work successfully. It's the same propulsion system that we used during our service module hot fire, as well as our pad abort test, as well as OFT-1. And had not seen any of these issues. So there was no reason to believe that we would have a concern here. We are looking at the length of time that the oxidizer was in the system to enable that permeation through the Teflon seal, as well as the environmental conditions at the time. We do have a purge in the vehicle that should limit the humidity in that area, but really the thought is that the just normal environment humidity was likely the source of that moisture in the valve, and that's what we're looking at now. And as we do see, as I mentioned, when we disassembled the valve, as we were back here in the factory, and we did see aluminum nitrate, so that that shows us that we did have oxidizer and humidity present in that area.
All right, thank you. We'll do our next question with Joey Roulette from the New York Times.
Hey, thank you for doing this. Question for John Ballmer. When was it first determined that Boeing couldn't launch until the first half of next year? And Boeing took a $410 million charge to do this OFT redo. And I was wondering if, who was bearing most of the costs for these troubleshooting issues, and will Boeing need to take something like another charge in the future? And then one other question for Steve Stitch. This problem was kind of found pretty close to launch, and that's something that the ASAP highlighted as a concern in its most recent meeting. And for both NASA and Boeing, I guess, are you guys reviewing how you verify flight readiness? Are you making any changes to what you guys do before launch? Thanks.
Okay, Joey. Let me start with some of those there, and then we'll try to answer all of them. So relative to the cost, NASA would not bear any responsibility for those costs that are within scope of our contract. It is a firm fixed price. So we're not expecting any charges to the government from that side. Let's see, relative to, and everybody asks this question, discovery, why didn't we know this before we went to the pad? So just to be clear, we had operated these valves, as Michelle said, we had operated them on 3 different fire indications. But we had, in the vehicle itself, we had cycled these valves many, many times in the factory as we installed them, as we checked them out, as we went through the environmental qualification testing. There was further vehicle qualification testing where these valves were cycled. And so we had no indication that there was going to be any problem with these valves. So we did load up the the commodities 46 days before flight, and we're looking at that. Is that a contributing factor? You know, our specification is we should be good for 60 days. So we had loaded it 46 days before. We thought we'd be fine. Once we have loaded the propellant and the oxidizer onto the vehicle, we cannot cycle those valves, you know, at random. We have to be at the pad. We have to be powered up, and so that was part of our procedures, was to cycle those valves 4.5 hours before flight. So we really didn't have any indication or reason to believe that those valves would not cycle. You know, part of that cycling is just to open them for our flight procedures. So, you know, will we do something different? And that's exactly what we're looking at. We're looking at, you know, maybe we load propellant later. Maybe there's some, you know, some different purge operations that we will make sure that we conduct to mitigate moisture. And so we're looking at all those things as potential to mitigate this problem going forward. And I'll turn it over to Michelle to add any additional that she's got.
Yeah, Don, I think you covered it pretty well. You know, I just add that the valves, as you said, went through full qualification efforts, acceptance testing of each of the valves. We saw them operate on the vehicle. We saw them cycle when we serviced. We cycled a couple of them post-servicing. So there really wasn't any indication during their operation prior that there would be an issue.
Yeah, and this is Steve. In terms of the flight readiness review process, I mean, I thought that process was very thorough, and we reviewed, you know, all the problems on the vehicle. I think the thing that was a bit of a surprise here, if you look back, we had a pad abort test in 2019 at White Sands missile range, and flew a very similar service module and had no issues, cycled the valves, loaded, didn't have any problem with permeation. We flew OFT-1 in December of 2019, and also no problems with that vehicle. It was out at the pad in a little longer time frame. We did a dry dress rehearsal. We did a wet tanking test for there, and so I think we didn't anticipate a problem at all. When we've seen issues with Teflon in previous programs in NASA, it's been a very subtle thing, and it's been hard to kind of sneak out. The Teflon is very important because it's very compatible with oxidizer. Most seals on these kind of valves are not compatible, so they use Teflon. Teflon, in this case, permeated a little oxidizer. Oxidizer has an affinity for moisture, and so perhaps it was drawing the moisture in, and then we'll understand that a little bit better when we get the valves off, take them to Marshall, disassemble them, and see where these corrosion products are. So.
Thank you. We'll now go to Jackie Waddles with CNN.
Hey, folks. Thanks so much for doing this. Just to follow up really quickly on Bill and Joey's questions, do we know any specifics about why there were only, 3 or 4 valves that couldn't become unstuck? I mean, is it possible there were, manufacturing defects for those, or anything about why, it was only some of them that seemed to be a persistent problem? And then also curious if you could provide kind of more exact timelines on when those oxidizers were added, on the 2019 test flight versus, the last time it was on the pad. If you can say, X number of days it was added, before the launch attempt or before the problem was identified versus what happened in 2019. Thanks so much.
Jackie, yes, I can answer that, and then John and Steve can add on if they'd like. So with regard to the first question of why those 4 valves perhaps remained stuck when we were at the VIF, we are through troubleshooting after that, we can see in the current traces of the valves that there is likely something going on with a number of the valves, and some are just better behaved than others. So we don't think there's anything unique necessarily in the valve. We found nothing different in the manufacturing or the lot data. We've gone through all of that. We don't see anything different really in the acceptance test data for these valves. And so, again, we think based on what we're seeing in our troubleshooting that probably the majority of these oxidizer valves have some, have some level of this going on in them. So I would say that, perhaps those 4 either were, had a little more of the corrosion products, or in the case of some of the valves, we didn't have the direct access at the launch pad that we had back at the factory, so we weren't able to do all of the at the vertical integration facility. We weren't able to put the direct heat on some of the valves that we were the others, and we could do that when we returned to the factory. So I would say that was a difference as well.
Hey, Jackie, this is John Ballmer. I'll just add that it was, 46 days for OFT2 from the time we loaded the propellant and oxidizer until August 3rd. And on OFT1, it was 35 days. However, we did have a wet dress rehearsal at 21 days into the cycle. Now, that was something that we did on OFT1 because it was the first time we were flying, and so the wet dress rehearsal was primarily to make sure that we had an integrated spacecraft and launch vehicle, that everything was operating correctly between the two. So we wouldn't necessarily do a wet dress rehearsal for every flight. It was just that first flight. But anyway, the answer to your question was 46 days for OFT2 and 35 days with a wet dress rehearsal at 21 days where we did cycle those valves.
Next question comes from Eric Berger with Ars Technica.
Hi, thanks for doing this today. A question for Stitch. Can you clarify how many missions that NASA's purchased from SpaceX and Boeing? I think it maybe is 6 each. I don't know, though. And will you need to negotiate a new contract with SpaceX soon since they're manifested to Crew 5? And then finally, sort of along these same lines, when Boeing is ready to fly crew flights and you're sort of getting into more regular crew rotations, will they alternate with SpaceX, or will they fly several missions in succession to sort of catch up? Thanks.
Yeah, happy to answer the question, Eric. So both SpaceX and Boeing were awarded a total of 6 post-certification missions on the contract, and they'll both have 6. So for Boeing, we've given authority to proceed on 3 of those flights, and then SpaceX we have turned on, as you said, through Crew 5. We know, today that the space station will likely be extended past 2024, and so we're in the process of going through those contract actions and figuring out how to add additional flights, likely to both contracts at some point. And that will become a little more apparent in the next few months or so of what kind of actions we're going to go do for both. In terms of the long-term plan, our model had always been, and we really want 2 viable space transportation systems, and having Boeing flying to the space station, as John and Michelle have said, is extremely important to NASA. When we get into the long-term rotations, we would like to see, SpaceX fly once a year and then Boeing fly once a year as well. And we're looking forward to the day that we get into those flights where we're handing over from a SpaceX vehicle on orbit to a Boeing vehicle and vice versa. So.
Next we have Mike Wall from Space.com.
Thank you all for doing this. Just a quick question about these valves. I just want to get a sense of, are these valves commonly used across a lot of different spacecraft and a lot of different missions? And if that's the case, has this sort of problem ever cropped up before in the research you've done? Is there something that has been observed, this sort of moisture seepage that leads to corrosion? Or is this something that you just hadn't seen in this type of valve before? Thanks.
I can start, and then maybe Steve or John can jump in as well. So these valves, they are, the supplier of the valves is Murata, and they are part of a product line of valves, so they're based on heritage valves that Murata has. There were some slight changes of configuration, dimensions, and such for Starliner exact, specific application, but they had not been used previously for oxidizer. So it's the first use. So they have a history, but they have not been used for oxidizer. That being said, though, they did go through a full qualification program, material compatibility program, and, had requirements that were consistent with our operation and the way that we did operate them on launch day. So that's the background of the valves. And as far as, and again, I'll let John and Stitch chime in as well, but there have been previous incidents of permeation of oxidizer through Teflon seals.
Yeah, I can talk. I mean, we have seen similar problems with oxidizer permeating on various valves. The one that comes to mind today is on the space shuttle, on the orbiter. We had primary RCS thrusters, about 870-pound thrusters, that were used to maneuver that vehicle, and we would have a similar problem before we instituted some purging when the vehicle was back in the orbiter processing facility. We would see, moisture forming with oxidizer vapor and forming nitrates, and then causing damage. And then we would get on orbit, and many times we would fire a thruster, and we would either fail that thruster off, the valves didn't open properly, or in a few cases it failed leak, and so we had to isolate a manifold. And so it took a little while to figure out what was going on. It was eventually a moisture. We remediated that problem with always having a purge on those thrusters, and then we're able to do some changes to the processing and eliminate the problem.
Next is Michael Sheets with CNBC.
Question for John Ballmer. I'm curious, if I understand correctly, these valves are supplied by Aerojet Rocketdyne, and I'm curious whether or not the company is re-examining its existing contracts and suppliers for those valves. Or are there other valves out on the marketplace that would be compatible with Starliner? And if so, have you guys taken a look at possibly purchasing different valves from another supplier for future Starliner missions?
Hey, thanks, Michael. So we've been working very closely with Aerojet Rocketdyne. They have been part of our investigation team. They have also involved their supplier, Murata, who's the supplier of those valves. We have looked at the valves. We've looked at the basic design. The basic design is sound. We are looking at, are there some slight modifications we need to make to the design? Is there additional purging that we need to do to make sure we don't get moisture? But no, we believe that the system design is sound, and so we just need to work through what the remediation is that's going to allow us to use those valves. We have not gone and looked at other suppliers at this time. Aerojet Rocketdyne is our propulsion system supplier, so they provide the entire system, and we rely on them to help us with making sure that we've got an end-to-end system that will perform.
Next is Hagen Warren. And Hagen, before you ask your question, if you can state your affiliation. Thanks.
Yeah, hi everybody. Hagen Warren with NASA Spaceflight. And thank you for taking my question. My question is for Michelle. How is the team able to begin repairing the system when the root cause isn't fully identified? And what does the current repair process for Starliner look like? Thank you.
Thanks, Hagen. So with regard to determining the remediation before we fully verified the root cause, I would say, going back to my previous comments, we've been working through the fault tree pretty diligently. Pretty early on, it was, we were narrowing down to this as a most probable cause. So knowing that is the most probable cause allows us to evaluate the remediation techniques, as John mentioned, so the team can continue to work those as we continue to work through verification. The work that we've been able to do here in the factory, the troubleshooting that we've been able to do with desiccant and with heaters has also, again, given us data that supports that root cause, as well as given us information that helps us determine that is the correct or that is a path for remediation. So all of those things we can do, as we continue to do the final verification of that root cause. So, pretty confident in that, in the path that the team's been working through on that. With regard to repair, so as mentioned, we are taking a couple of the valves off for further verification. Those valves will be replaced, so they'll have clean valves in their space, in their place. And then, as John mentioned, we are looking at what we can do to limit the moisture that could potentially get into the valves, such as desiccant, maybe a slight valve tweak to prevent moisture ingression, as well as looking at, at least for service module 2, adding the addition of heaters to the valves that then allow you to free up those byproducts, those corrosion products, and allow the valve to cycle. So the team is designing that as well, and we'll have a design review in the next couple of days on that, but that would be a second part of that repair and remediation. And again, through the troubleshooting efforts that we've been able to do on the factory, we've seen that be successful in freeing up the valves, and so that, that gives us confidence that we'll be able to move forward with that remediation plan.
Next is Emery Kelly with Florida Today.
Hey, folks. Thanks for taking the time to do this. I just wanted to follow up on Bill's question, potentially to Michelle. Around that launch time, we had some pretty intense thunderstorms, if I remember correctly, and I just wanted to double check it. So far, is the idea here that it was just general crazy Florida humidity, or potentially these storms that rolled through? Because with the former, Florida's always a little crazy humid, so I'm just trying to wrap my mind around where this humidity could have come from. Thanks.
Yeah, Emery, I can address that. Yes, so you are right. We did experience some storms while we were out there, both at the VIF and then when we rolled out to the launch pad. And in fact, just the day prior, we had a pretty significant storm. We had some indications on the vehicle at that time that there could be condensation in the vehicle or some type of water ingression. Once we were able to get to, that was on is on our fault tree. Once we were able to get to the vehicle and see all of the seals that are between the crew module and the service module, we don't see any significant leaking, so we don't think that it was just pure rain getting into the service module. We do see some indications of moisture or condensation or having been present, which again supports the fact that within the service module, based on the environment, that we were getting some condensation, which again could contribute to this or support this root cause. So we're seeing both, we're seeing that physical evidence on the vehicle, but it's not just, we see no evidence of just pure rain ingression. It's more of a condensation effect.
Next is Paul Brinkman with United Press International.
Hi, yeah, thanks. Question for Steve Stitch. I just want to zoom out a little, I guess, like astronauts and access to ISS. Is NASA assuming that Boeing will succeed eventually? I understand NASA has full faith and confidence in the company selected to provide commercial crew launch, but these delays are not insignificant given the original schedules. And I believe there was a third proposal that NASA supported earlier. So in a general context, what has NASA done or is doing to ensure success in case any commercial crew launch provider can no longer deliver for whatever reason? If a provider can no longer deliver in a specified time period, will NASA continue with only one provider, or will another provider be brought in, and when or how quickly would that happen? Thanks.
Yeah, thanks for your question. In the near term, what we have continued to do is we have a certified system with SpaceX, and at the end of October, we're going to embark upon our second crew rotation mission, where we'll have the Crew 3 vehicle launch and come up to the space station, and we'll return the Crew 2 vehicle. And then, we've already talked about the mission in the springtime. April 15th or so is the date, and that'll be Crew 4, which is another SpaceX crew rotation mission. We have every confidence that Boeing will be flying crew soon. I look back to OFT-1 and how well much of that spacecraft performed on orbit in terms of the systems, the guidance and navigation systems, propulsion systems, the thrusters on the service module, and all the rest of the life support, the avionics, all performed really well. That was a great checkout of Starliner, and it performed well. Now we've found an issue on the service module that we got to go work on. Michelle and John have a good plan laid out of how to get there. Getting these valves out was a huge step in determining root cause, and we've already seen some success with remediation of moisture on the service module and also using heaters to free the valves up. So, we'll get this problem solved, and then we'll have two space transportation systems like we want. We'll have Boeing and SpaceX both flying and fulfilling the needs of our flights, and so that's our plan for the future. So.
Okay, but I guess I still want to know, does that mean you're assuming that Boeing will be successful at some point?
Yeah, I have no reason to believe that Boeing won't be successful. I've seen the spacecraft up close. We've tested the parachute systems. We did a pad aboard test. We're working through the remainder of the issues with this particular service module and the valves, and so I don't really see any scenario where Boeing's not successful. The company is committed to these flights with NASA. It's important to Boeing. I can tell from the diligence of the team, the resources they've applied, and quite frankly, the attitude, professionalism, and the can-do spirit of the team to go solve the problem and move forward.
Okay, thanks.
Next is Micah Maidenberg with the Wall Street Journal.
Hi there. I just wanted to go back to the humidity. Maybe this is for Michelle. At any point did Boeing sort of account for humidity in this launch? Like, where would that come in if it did? And the second thing is, are there any dissenting views about what caused the moisture in the system, or is the thought that humidity caused it? Thanks.
Yeah, Mike, I can address that. So we do assess humidity within the requirement space. So the specifications do say that we need to be able to operate in humidity. The specifications that go out to our suppliers. We do also have purges on the vehicle to maintain the dry air and prevent moisture ingression. Again, it was a humid time of the year in August. We've looked at dew points. We've looked at temperature dew points while we were out there at the launch pad, and also our the purges. And like I said, we've physically seen some evidence of condensation within the service module. So all of that again supports that we had some of that perhaps going on. But and that'll be, we'll continue to look at that going forward as part of the remediation and ensuring that we don't have that. Again, the previous tests that we talked about, OFT-1, pad aboard, SM hot fire, we did not experience that, and there was the same valve, same propulsion system. As far as dissenting views of where the moisture is coming from, again, the team is working very, very closely, the Boeing NASA Aerojet team, so there is coalescence around this probable cause. We continue to work through each branch of the fault tree to make sure that before we officially close a branch, it's got buy-in from all of those, from the entire team, again, working very, very closely. There was some discussion early on, because this is the vehicle that we used for environmental qualification tests, so there was some discussion early on about whether the referee fluid that we use, the environmental qualification test consists of acoustic testing on the vehicle, thermal vacuum testing, and electromagnetic testing. And so as part of the acoustic testing, you need to simulate the commodities in the vehicle. And so we did have HFE in the oxidizer system, but that was chosen specifically because it doesn't, it's not a water-based commodity. And so there was discussion on that. We don't believe that that's contributing the system was cleaned, purged after that. We have valves that were removed after EQT and replaced, and with the new valves that are on the vehicle also experienced this issue on the launch pad, so valves that never went through EQT. Then we have valves that were removed after EQT that we've put now through acceptance tests again and seen nominal performance of those valves. And so, you know, indications are, based on the selection of that referee fluid, that is not a contributor, but that's certainly a discussion we've had.
Next is Jeff Faust with Space News.
Thanks. A couple of quick questions. One for Michelle. How long does it take for this corrosion to be created on the valves when the oxidizer and moisture interact? Does it happen very quickly, or is this something that takes time to build up? And then for Steve, do you anticipate NASA requesting or requiring Boeing to perform any specific tests to verify that the fixes that they make to the valves are in fact successful and you're ready to proceed to flight?
Jeff, I'll take the first one. So with regard to the time of that reaction, so the reaction between the oxidizer and the moisture that creates nitric acid, that's pretty instantaneous as soon as you get those constituents together. That's pretty quick. So then you have the nitric acid, you know, sitting there near the stainless steel or aluminum, and then that's a corrosion, you know, product or a corrosion process. And that is, you know, that we've determined could occur in the time frame that we had the oxidizer in the system in those, you know, 46 days, as John mentioned.
Yeah, in terms of NASA requiring tests, I mean, one of the tests that we've already identified that I think is going to be very beneficial is, and I talked about this, as sending some valves out to white sands, and what will happen is we'll try to recreate the exact scenario that a valve went through. In other words, expose it to the environment in the C3PF and allow oxidizer to permeate across that Teflon seal. And oxidizer tends to want to suck water in, and that's what's causing this nitric acid that Michelle talked about. So we'll be able to replicate that whole time frame, and then we can sort of see how fast the corrosion grows. And the way we can do that is not by necessarily taking the valve apart, but then we can measure the current required to open and close that valve over time and see how it's degrading and see that performance. And so we'll take a number of these valves out to white sands and do that testing, and I think that is a key set of tests that we have planned to get to flight, in addition to all the other materials testing that is ongoing right now. And we're a part of the team. We are a voting member relative to closing out fault tree blocks, and then we sit in on developing the test together. So right now, the test plan that Boeing and NASA have laid out is the one that we're going to use for flight. So.
Next is Robert Cottinger with Spaceflight Mag.
Oh, hello. My question is for John Ballmer. With this latest delay, I mean, is Boeing looking at just not making any profit on Starliner, or is the latest charges going to wipe out any profit you could make?
So I won't speak directly to the profit part of it. I will speak to, like I said, there's no additional charges that will be going to the government for this. This is something the Boeing company will make sure that we've got covered as we get this vehicle prepared. I will say that we are 100% committed to fulfilling our contract with the government, and we intend to do that. And so going forward, our focus will be on getting OFT-2 to flight the first half of this year, and then getting CFT to flight as soon as possible after that.
Next is Ken Kramer with Space Up Close.
Hi, thank you for doing this. I want to get back to the moisture question. I'd like to know in more detail, what are you doing to actually replicate the moisture conditions and find the source of the condensation? Because it is always humid in Florida, and your pad abort test, I don't know that you had and your hot fire, I don't know that you had hot, humid conditions when you did those tests. So I want to hear a lot more about the intentionally inducing moisture and drenching these valves maybe with water to find where it's coming in. Thank you.
Okay, I could start on that one. So Pat, just to close on that one, so Pat abort did take place in New Mexico, right? So not significantly humid conditions. OFT1 was here in Florida, as well as OFT2. So we have looked at the difference in humidity conditions between those two times of the year. Certainly, we do see more humidity in August. Probably not that's probably not surprising for Florida, August in Florida. And again, we do have purges and such. There is on the side of the valve that we talked about, the valve positioning indicator, where as we disassembled here at the factory, where we saw the aluminum nitrate products, there is one small vent hole that could allow moisture or environmental conditions, environmental air to get into that area. So that's where we believe the path has come from. And again, going forward, we have since put desiccant in that area to prevent the moisture ingression and to make sure that side of the valve stays dry. And so, that's what we're looking at going forward. And we'll, look at the purges. We'll add the heaters, and we'll look at the length of time that we've got the oxidizer in the system to prevent those constituents from getting together and forming the nitric acid and corrosion.
But what about re-engineering that vent hole? Desiccant only, that doesn't prevent the water from getting in.
The desiccant is providing a dry environment in that area. So we've seen, again, that's as part of our troubleshooting that we've been able to do on the factory and prove out. So it certainly prevents the moisture from getting drawn into that area. That's what we've seen. We are looking at options for the vent hole.
All right, thank you.
Yeah, I would just add in that we don't anticipate that this was because the valve was, submerged in water or subjected to liquid water. This is more of, picking up moisture from the ambient environment. And like Steve said, the NTO acts almost like a sponge to absorb that moisture. So the moisture is attracted to the NTO, causing it to form the nitric acid. Now, also Steve mentioned that we are going to run some tests at White Sands, and we are going to try to replicate the conditions that these valves went through. So we will be taking them through a high moisture or a high moisture environment and seeing what the effects are on those valves in test on the ground.
Okay, thank you.
Next is Irene Klotz with Aviation Week.
So, for Steve, regardless of the availability of an Atlas and regardless of station ops, what is the minimum amount of time that you're showing on schedules between OFT2 and crew flight test?
Yeah, I wouldn't say we have necessarily a minimum time identified. And one of the things that John has not talked about, and we are on a full court press to get through this OMAC and RCS isolation valve issue, but we continue to make a lot of progress on the CFT vehicle. And so really, crew flight tests would be gated by, when we think we've got the root cause identified on OFT2, a successful OFT2 flight and good data from that flight, and then, we'll have to lay out a time frame of when then that CFT flight would fit with the station schedule. For right now, our crew rotation missions, you've seen them. They are in the spring and the fall, and we have a time frame where we'll have both ports sort of tied up. But then other than that, we'll just have to find that right time for CFT. And maybe John can talk a little bit more about if he sees some number of months or timeline between the two flights. I don't necessarily see that. if we can get all the, and we have a certain amount of certification work that we need to get done for crewed flight tests. We have a number of VCNs and hazard reports and tests that have to be done on the vehicle. As long as those are met successfully, then, and a successful OFT2 flight, then we would get into CFTs.
Hey, Irene, this is John. So we're looking at the OFT2 flight first half of 2022, and we would look at CFT, maybe by the end of the year. We'll have to, like I said, our first focus will be on making sure we get OFT2 launched successfully. And then after that, we'll look at the CFT schedule. So, we like to see 6 months between flights. Something on that order. There is some turnaround time, there's some refurb time. But as Steve said, we are aggressively working the CFT vehicle in parallel with the efforts that the investigation team, the remediation team, and the test team is working on the OFT2 vehicle.
Thanks. And Steve, when do you expect to add a third crew member back to the crew flight test?
Yeah, we haven't talked much about that. It's probably too early to speculate. We'll have to sit down with the astronaut office and go through that discussion, and we just haven't had time to do that, Irene. So.
All right, we'll go over to Lauren Grush with The Verge.
Hi, thank you so much for taking my question. I'm curious if you know what might have happened if you hadn't caught the valve issue before launch and had taken off anyway, and do you have confidence that the abort capability would have been able to counteract whatever negative side effects might occur? Thank you.
Hey, Lauren, I'll take this one. This is John Ballmer. So, that's exactly why our procedures prior to launch were to go through, and we very methodically go through and check out all the systems. This was one of those things that had to absolutely work, or else we would not fly. So this is not an issue of if we had launched and not known this, we absolutely knew that these valves would be in the right position before launch.
All right, now we'll circle back to Bill Harwood with CBS News.
Yeah, hi guys. Just two real quick ones from me. Are any of these valves on this service module being replaced, or are you cleaning the valves and leaving them in place, or using the same valves, I guess I should say? And in all cases, did the valve itself fail to move, or was it the position indicator, or both? I was confused about that. Thanks.
So we are, as we've mentioned today, we're removing 3 of the valves. Those will be replaced with new valves. So those 3 will be replaced. And then as far as the valve not moving versus the valve positioning indicator, the valve is not moving. We have verified that the valve positioning indicator is working. That was a branch on our fault tree. Could it just be a bad telemetry indicator? But that has since been ruled out. So we do believe that it's in seeing in a number of ways, we do know that it's the valve that is not moving.
Okay, but the valves that are staying on the vehicle, do you clean those, or how do you get them in shape where they're ready to operate normally?
So those will all be subject to the remediation efforts that we've talked about, including desiccant, potential heater addition. Right now, it's not a baseline plan to clean those valves or flush those valves. That has been done on programs in the past. So there are some discussions, but right this moment, the remediation includes the limiting of any humid air, moisture ingression, as well as adding heaters to break up any of the products that might be created for service modules.
I understand. I'm sorry. Can I just squeeze this last one in? You mentioned corrosion products in the valve, though. I'm curious as to, is that a physical interference that's keeping the valve from running? I'm just wondering why you don't have to clean it. And I promise that's my last question.
So at this moment, we have all but one of the valves have been shown to operate. And the one that I mentioned we're preserving for the root cause verification. So we haven't really tried all the tricks to get that one to move. So we've been able to operate them through this combination of desiccant and heaters. So at this point, right now, we believe, and we're in discussions again, this would have to, we still have to finalize all of this as we proceed to through flight rationale and such. But we believe that will be our remediation path.
Thanks.
And that'll exhaust our time for today. Thanks to everyone for their questions, and of course to our participants today for answering the questions. You can follow up and check out the latest status always on our blog, and of course at nasa.gov/commercial crew. Thanks everyone for joining today.
And this concludes today's conference. Thank you for participating. You may disconnect at this time.